Back again on the 465B. We're going to try a recap on all the filter caps. So parts have arrived from DigiKey. We're going to take this board off and then access underneath. Hopefully that's going to fix our issue, because we've got like 300 millivolts of ripple on all the rails, which I'm hoping is throwing everything out and causing our issues, but we'll find out. So pull these connectors. Scope's been powered off for a couple of days now. We're going to have to desolder that B and C input, which is in fact two B and C inputs, which is annoying. Very annoying, in fact, but not much we can do about that. And there's the connectors off. So, should have a free board almost. Oh, God. The problem with this thing is it's so old. There we go. Now, we can see our cans. Oh, and then you go, well, is it worth getting stuck into the delay controls? I didn't really see too many issues with this when I had it apart. So we're going to flip this onto its back, I think, change the tip on our iron and start trying to get some of this solder out. I don't know how high hopes I have. I have heard of people just taking a hacksaw blade to these and taking them out like that, but we'll try one and we'll see how we go. Oh dear, that's a BNC. This is probably the limit of my skill level. I definitely don't fully understand all the ins and outs. On the upside, all our edge connectors look okay. And I think what I'll do is I'll try and hit these with a bit of solder sucker first. If I can get them cooled down enough, and then we will go from there. Righto. I'll put the big tip on the hacker. We'll pick up all the various bits and pieces we just dropped, hopefully without burning ourselves. We'll screw the whole lot back together and switch it back on. We might even try a bit of flux, maybe. Again, this is a little bit of trial and error for me. So, yeah, I'm not sure how this is going to go. It looks like hard work. In fact, I think even there, I'll just zoom you in a bit. It looks like part of the board's even lifted from the factory just there. It's only a tie between a couple of the negative legs, I think. Yeah, they're a four-leg cap, which is very, very annoying. Right, well, our first attempt is going to be solder sucker with some flux and the big tip on the iron. Oh, hello. Wasn't too bad. Flux definitely helped, but there's a lot of solder in there. A lot of solder. Oh, hasn't even touched the other side of it. Let's put some braid on there and see if we can't suck some out. Starting to get there. Definitely looks like a hole there. The issue being is that there's a lot of solder on the other side of it too. So it is yeah, pretty heavily soldered to the top of the board too. I won't lie, the hacksaw blade is looking more and more likely at this stage because that is just a nightmare. And I think if you hacksawed straight through here, you'd have a pretty good chance of just being able to pull the lug out. Similar to what I'm going to attempt to do now. With a bit of heat applied. Even that's not the easiest. Yeah, there's heaps of solder up there. I just can't really see how you're going to get enough heat. Hoping that's the tip that's burning on that and not anything else. There's no power. Yeah, I really think that there's if you saw directly above here, there's not a lot of areas for the metal shavings to go in. You might put a barrier there or something. It's all just going to fall straight down anyway. I'm thinking that that's going to be the best way to go, because getting into there, unless you decan the caps, is going to be hard work. We can try and suck some more, I suppose. But I just don't know how we're going to suck it right out from the bottom of it. Yeah, I just don't know. Like, I've snipped this leg here off, but I don't think it's going to make a huge amount of difference. Let's see how we go with this. Good job. Well, we're definitely getting solder off. It's just the other sides that are going to be. And you know, with a standard cap, you can just sort of heat two up and wiggle it, but I don't know if that's going to work here. We can try it. We've only got 3 on this one to play with. In fact, let's try and suck as much as we can out of that. Look at this new fancy low melter go. It's like 30, it was $30 for this little tiny roll of it, so. No, it's definitely doing something though. It's interesting. I'm probably being impatient by not using the flux for that. Let's just try and see if we can heat this up enough to get it out. In fact, I'm going to put some. I'm actually going to put some my normal solder in, because I just don't think we're getting the heat transfer that we need. That one there, it's going to be our issue. All right, let's see. All we're doing is really flexing that board, which I don't like any of that at all. In fact, it even looks like we may have lifted a pad here, which is poor soldering on my part, but it's also not connected to anything, so it's going to lift easy. I definitely think the hacksaw is going to be the go, because then we can get back underneath here with wick and give it a really good clean up. Maybe with a solder sucker you could do it, like an electric one. but like just getting enough heat to be able to suck any of that solder off the bottom of this. No, nowhere near it. So I don't think I have any hacksaw blades handy, so it's going to be off to Bunnings tomorrow perhaps. So you remember when I said that this repair was probably at the limit of my skill level? Well, I think we're right. I've hacksawed the main power capacitors off, not without some damage, unfortunately. The hacksaw had a small little nub on the end that I didn't think too much of at the time, but of course as I've been sawing through, it's been hacking away at some of the traces, and we've done a little bit of damage to the mask here. So I've repaired the two traces that were actually cut. We've got all the old caps out. I'm just in the process of cleaning up these pads in order to get new capacitors in. I'm just going to mask up the areas that could present a problem of shorting on the bottom of caps when we install them, and then we're good to go. But I'm glad this scope is not like a museum quality piece. It's pretty dirty, it's pretty beaten up. I don't feel too bad, but definitely a learning experience for me, and something I definitely won't repeat in the future. These caps, you know, with the earth cans with 3 negative terminals on them are this design is a pain to work on, only because it takes so much effort to get them in and out, and you risk doing so much damage. These traces just lift at the drop of a hat, particularly the pads. They're really difficult to work on. It's quite hard work. And then once you get the new caps, you obviously you've only got 2 terminals to play with, so then you're going to have to bridge certain ones to make sure that the grounding's correct. It's it's a bit annoying. It's doable, but as we can see here, we've got a little bit of damage, and particularly this trace here has had a bit of capacitor juice leaked on it. It's still connected. I'm not quite sure what I might just bridge that just in case, but the other option is to just install the capacitor's negative terminal over to here instead. Positive goes here, negative goes here, and we'll remove even using that pad, but we'll have to jumper it because there is a common earth pad between these three terminals here. Anyway, I'll get stuck into that. I'm going to mask these up. I'm probably going to mask up a little bit. I've checked everything else. It doesn't appear to be shorted or anything like that, and there's no other breaks that I can find. So I'll mask up what I can, and then we'll get stuck into installing some capacitors. So here's the completed, well, new caps in the power supply. I'm a bit disappointed in my workmanship with this one. It was probably a bit harder than I anticipated, and the traces on this just lift at the drop of a hat. So I believe it's all sorted. I'll give it a quick tidy up with some isopropyl and get rid of some of the flux. Apart from that, there's a few bodge wires to line up some of the earth points off the old 3-pin or 4-pin cans. I think it'll work. So we'll bring it up in a tick with the multimeter on the 55 volt rail, and we'll see if this has fixed our voltage problem. Okay, we should be ready to power it up. I brought it up on the dim bulb, but it doesn't, well, given how much current the CRT draws on startup, it just won't run. So we're going to give it full beans and see what happens. So 3, 2, 1. We're on, and already our 55 volt rail, 64.5. So I'm going to kill that. Just change the VARAC a little bit. Yeah, no, that's not, that's down to 200 volts now, and we're still not even close to 55. A thought that's just occurring to me, I'll just switch this off. Given I'm changing the VARAC, or changing the voltage on the VARAC, and it's changing what should be a regulated output, something's not regulating. And having changed the caps, it's obviously not the caps. I'd hazard a guess with the same voltage, we can just check, see how much AC ripple we're getting. We're getting still 430 millivolts, which is way too much. I think we've got an issue in maybe the regulation feedback. There are two chips, CA1458, so I'm assuming they're like a dual op amp. I wonder if we just switch the chips around. They're just under here. I wonder if we just flick them around and see if that'll change any of our behaviour. Luckily they're socketed. Because I've been through the power supply and I've checked almost everything that I can. And there are a few components that have drifted, but to me, and my initial troubleshooting did lead me down the path of something being amiss with the regulation, but I sort of thought, oh, maybe given the amount of ripple, you know, maybe coming out of those cans, that might be causing an issue. I wasn't too sure. But now I think about it, it seems much more likely that that high voltage on the 55 volt rail is caused by something not regulating as it should. So we switch the chips around. We'll go back, we're on DC here. Let's try that again. Now we get a stable 54.9, and that's it. 200 volts. So we'll just crank the variac back up. There we go. And we've cranked the variac back up, and interestingly enough, that's regulating. So I wonder if this pot, adjustment pot over here, will now work, and it does. So let's bring that down to 55. All right. So what this makes me think is that one of those op amps is bad. Check a -8. Yeah, that's spot on. 15 volt rail is good. And our 5 volt rail is at 3.5 and a little bit wonky. And our 110's at spot on 110. So, I think we may have solved this one. That chip is bad. If we look at our schematic, I'll just turn this off. Where's our 5 volt rail? There it is there. It runs into U4206A. And funnily enough, our 55 volt rail runs into U441A. So I think the A side of that chip that I just swapped over up into here is bad. Now I have some LM1458N chips that I hope will work. I'm not very good at this because these chips are pretty old. Obviously, these may not be directly interchangeable, but if they're just a dual op amp, I'm tipping they will be. Not all that complicated. It's nice having sockets. Although, it just doesn't want to go in. Okay. Well, I guess we'll hook onto the 5 volt rail and see what happens. Aha! We're at 4.98. And we have a trace on the screen. interestingly enough, it's still not quite right. We'll bring you back around once I get this sorted out. Well, as we can see here, we've got a trace back, which is fairly exciting. Everything seems to be working. The triggering's come back. I haven't actually tested all the controls or anything, so we'll go through and do that. But I have managed to get a pretty decent trace on there, so I'm pretty happy with that. We'll have a play around and come back. Okay, now our 5-volt rail's back up. We can turn it on and see if it works. Or more to the point, see if we can put a trace into it and see if we can put a signal into it and get a trace. We have a trace on the screen, which is nice. That's going to be, we'll turn on channel 1. Already I can see the geometry is out a little bit, but it's not too bad. All right, let's plug in a signal and we'll see how we go. Hertz or so. Kilohertz. So we've got, I don't know if you can see that on the screen. Where is our intensity? There we go. I don't think the refresh rate's playing nicely with the iPhone camera, but our triggering, this is what was causing us issues. There we go. Ah, look at that. Our volts per division work. Yep. Funky with the triggering level that low. Yep. That's good. Our time seems pretty good too, actually. The pots aren't noisy at all. I'm very surprised given how dirty this instrument was when I got it. So that all seems happy enough. We'll try channel 2. There's channel 2, triggering on channel 2, or normal. That's triggered. That seems to be working perfectly fine as well. A little bit of noise on the pot, but nothing that's really affecting the actual output, or the display, I should say. So that's good. I don't know if our invert works. It's a bit funny. Yeah, I don't know enough about that switch to know if that's correct. Beam find. Oh, it's interesting. So we get a beam find halfway on the switch, but then if we push it all the way and it disappears, I wonder if that's... No, intensity does nothing there. That's interesting. That probably needs a clean. What else? CRT seems pretty good. I'm not even at half intensity there, and it seems pretty happy. A bit dirty under the pot. Might need a clean. I wonder if our delay works. So if I go A intensified by B, that all looks good there. I do not think our delay is working. And if we go to B delay, we have no signal. Yeah, even with the intensity all the way up, the B intensity, that's cranked up all the way already. We can try and half beam find. No, we got nothing. So there's an issue in, I think, the delay circuit. I'll have to have a bit of a muck around and see if I can work out what that is. Because, yeah, I mean, it's not, oh, God, I've got a T465 here that I've got a TDS here that can do delayed stuff, so it's not a big issue, but I wouldn't mind having a look at it just as an exercise. But as we can see there, we have signal coming in, our display's fixed. So what it really, I don't think I needed to replace all those caps necessarily to get it running again. It was half of that op amp. And I guess a bit of a learning experience. If you're adjusting the voltage through a variac and what is meant to be a regulated voltage is changing and not being regulated, then it's a good indication that there's an issue with regulation. So for me, I'll put that one in the back pocket for use at another time. What I'm going to do is clean this panel up and have a look at that delay circuit, but that'll be probably another different video. But clean it up and get it up in the rack, and it's a pretty usable scope at this point, with the exception of that small issue with the delay. Given that it's got no signal, I have a feeling it's going to be something that shouldn't be too difficult to track down, but we'll see. I know that circuit's, well, will probably be quite complex, to be fair. Yeah, magnification works. Position works. So far, so good.